The next structure is a sphere. So how do you put it across on a sheet of paper? Just draw a circle, pick a center and dashed line, and this is of R unit. That would be your radius. The curved surface area, the total surface area of a sphere is given by 4 times the area of the circle. That's how you guys can remember. That is nothing but 4. What is the area of a sphere? Sorry, not area of a sphere, area of a circle. 4 pi r square. So any given sphere, theoretically we can cover it up with the help of 4 circles. That's how you can remember it. If I happen to take 4 circles, if I cut 4 circles, I can cover this sphere with the help of these 4 circles. Again, it's just theoretical, it's not practical. So this is how you can remember. So we can make a mental note that we can cover a sphere with 4 circles. It's only to remember. This is not practical. Okay, so this is how you can remember the curved surface area or the total surface area. Why am I talking about total surface area and the curved surface area to be same? Because there is no flat part. So the curved surface area or the total surface area of a sphere is one and the same. Is it not? There is no flat part. So these two are one and the same, and so we can remember the formula to be the same. Next is the volume. Volume of a sphere also has this 4 pi into r factor also. I mean, all of this looks the same. Additionally, we have divided by 3 and cube. So volume is always cube, is it not? So basically your formula is 4 by 3 pi r cube. So this is your formula. Okay, the cube part is, remember, is because of volume is of 3 dimension. It has to be cube. The powers need to add up to 3. Right? So let's recall, total surface area is 4 times the area of a circle. So since this is a square, this is of, the powers add up to 2. And so this is of 2 dimension. Next is the volume, which is 4 by 3 pi r cube. This is 3, right? The power is 3. How you ignore the constant? Look at the power of the variable. So it's 3. So this is obviously the powers add up to 3. We know that volume is 3 dimension, so this should be 3. As simple as that. So this is 4 by 3 pi r cube. Okay, it makes sense. Now we'll begin with hemisphere. Hemisphere is nothing but half of a sphere. Of a sphere. How does it look? So if I take this sphere, cut it, right, you will get the hemisphere, half of it. Right? Does it make sense? So can you guess the volume of this? I'll directly go with the volume. It would be half of the entire sphere. So entire sphere is 4 by 3 pi r cube. So basically this would be equal to 2 by 3 pi r cube. So you need not by heart this. Volume is basically half. Right? It makes sense. So how do you draw this? Quite simple. You draw a circle, not exactly, but yeah, in this, from this view, yeah, this way, and indicate that it has a radius of r unit. Again, there's only one factor over here, only one variable, that is r. Okay, now let's look into the curved surface area. Obviously the curved surface area 2 is half of the sphere, right? The entire sphere would be something like that, which we have seen before, but we are cutting half of it. So obviously the curved surface area will be half of 4 pi r square. So basically we just need 2 circles to cover the curved surface area of a hemisphere. So 2 pi r square, that is 2 times the area of a circle. Okay, so this is your curved surface area. Next, total surface area. Why are we talking about total surface area over here? Because it has a flat surface, right? This is your flat surface. Can you see that? It's very clear. It has a flat surface. So we need to talk about the total surface area. It is nothing but curved surface area of the hemisphere plus the top or the base, whatever you guys want to call it as. So what is the structure of this top or the base? Well, it is nothing but a circle, is it not? So we have 2 pi r square plus pi r square, because even that too has the same radius. So pi r square, end of it is 3 pi r square if you want to add it up. 2 plus 1 is 3 pi r square. But yes, again as usual, I would prefer you guys understanding this part, don't by heart the last part. So I'll just erase this. Yes, that answer is correct, but I don't want you guys to remember it this way. So I'll just put a scratch. You guys can do the same. Remember it this way, not as 3 pi r square. Okay, again, conceptually you need to be aware because you're going to use it in quite a few places in a different way. So you need to be aware of it. Okay, so here too dimensionally it's the same. It's the extension of your sphere, so I'm not going to do that. So please understand, over here we are making use of the same formula, that is area of the circle, again and again in various places. So remembering area of the circle, circumference of the circle will help you guys a lot in most of the numericals, in most of the formulas. Okay, so please pause, write everything that you see on the screen.